Very good evening, students. Today, I'm going to discuss the topic structure and union partly because one single class is not enough to complete the entire topic. Today, we just start this topic. So, before starting this topic, structure and union, let me explain why we will learn this chapter or this topic. So, to understand this clearly, I will just move back to the topic array. Before learning array, what have? We have only normal variable. What is the meaning of a variable? Which can store a value. And at a particular time instance, we can store only one value inside a single variable. Suppose if I write int a equal to 5, and in the very next time when I'm writing a equal to 6, that means the 5, the value of a previous value of a 5, it's overwritten by the new value, which is 6. So at a single time instance, we cannot store more than one value under a single variable name. That is the point, that is the limitations of normal variable. To overcome this problem, we learned or we introduced the topic array. What is the definition of an array? The definition of array is it can store homogeneous type of data elements, right? The array element stores in the contiguous memory location. First point, it's a linear data structure. Second point is it can store the homogeneous type of data elements. Third point is the array, the address of the elements are contiguous. That means array element stores in contiguous memory location. And the fourth point is all the values are sharing the same variable name, because we already seen that ARR 0, ARR 1, ARR 2. The name of the variable is ARR, and this variable, each and every element we can access by using the same variable name, and here the index of an array plays an important role. So this much we have discussed in the chapter in the topic array, right? So now I'm starting my discussion with a real life problem. Consider a situation where you have to store the details of all the students in your class. So what I try to do, I try to store the details of all the students. In your class you have 60 students. So I want to store the details of all 60 students in a program, or rather in a variable. So what are the details? What type of details for a student you have? Just like ID, name, address, phone number, email ID, SGPA, this type of data. So if you make it design, if you check the data type of this data, this field better to say, your ID field consists the data type integer, right? Name, It's a string, and we already know what is the meaning of a string. The meaning of a string is it's a nothing but a character array, ends with null character, right? This much we already know. So when I am talking about the name, that means it is basically an array, character array. Next, address, another character array. So name, address, phone number, phone number, which type of integer, email ID, which type of data type of email ID, another string. So definitely another character array. Fine. And if you want to store the marks of a student, so what is the data type of marks? SGPA, YGPA. Definitely it's a float value. So data type is float. Now my question is, forget about 60 students. If I want to store the details of only one student, this details, ID, name, address, phone number, mail ID, SGPA or YGPA, and other marks. Array is not the solution. Why array is not the solution? Because the attributes or members that we are just discussed are not the data type of these attributes and or the members are not homogeneous, not similar type of. If it is homogeneous, we can easily use an array to store the data of a single student. As because it is not homogeneous, so array is not the solution, so we need to substitute an array, and which is nothing but a structure. And if you look the formal definition of structure, I am showing you what is the formal definition of structure. This is the formal definition of structure. A structure is a user defined data type in C or C++. A structure creates data type that can be used to group items of possibly different types into a single types. So try to understand the meaning of first line. It is a user defined data type. The data type that we have learned so far, like integer, character, float, double, these all are primitive type of. They are defined by the system, not by the user. But the structure is defined, it's a kind of data type which is defined by the programmer. User means programmer in this case. As I am the programmer, so I have to define this data type, rather my own structure. And what structure does? It basically group items, possibly different types. It may be different, may not be different. Because when I am talking about the attributes of a students, rather members of the student data, what are the members? ID, integer, name, address, both are string. So some of the members are of similar type of, some are the different types of, or maybe all are of the same type of, or all are of the different types of. That is depends upon the situation or problem statement for which we are defining our own structure. That is not dependent, that is not that is distinct for every different cases. So that's why the term mentioned, it is possibly different types of, because when the data types are different, array is not the solution. So to solve that problem, we introduce this concept structure. So this is the formal definition of structure. So it is not a primitive data type. This data type is defined by the user. Now I am going back to the previous slide. How we implement structure in a program. So definitely we need to define, as because definition says user has to define this data type. Fine. So that's why I have taken this slide from Greeks for Greeks. So they have given the structure name Greeks for Greeks, and the syntax is struct. The general syntax I am talking about. Struct. It's a tag name or structure name. Tag or structure tag. It's a tag name of the structure, better to say. So this is the starting part of the structure definition. Struct is the keyword. Then after you have to mention the name of the structure, or the name of the structure can be termed as a tag name. And this tag name is optional. You may omit this tag name, and I will show you in which case you may omit the tag name later on when I discuss about the example, rather implementation part, rather programming part of this structure. So what they consider in this slide, their structure name is Greeks for Greeks, and the members are char underscore name. Char is the data type, underscore name 10. So their first member is an array, rather character array, rather string, better to say. It's a string. Second member, an integer array, up size 5. Third member, float salary. So what are these three? These three are called members or member variable of the structure. Note it down. The members or attributes of the structure is called member variables of the structure. Fine. You cannot directly use these members. Before coming to that point, note it down. After completion of the definition part is written inside a block. It's a opening braces and closing braces, and it is terminated with a semicolon. And the semicolon is mandatory. If you not provide it, if you not give it, you will get a compilation error. So it is mandatory to give. So if you consider our example that I discussed before starting this presentation, the structure of a student, what are those members? ID, name, address, phone number, mail ID, SDPA. 6 members I talked about. And all 6's are what? They are the member variables of structure. And say, according to our example, I give it the name of the structure as student. So what I have to write in this place? Struct student. First member will be ID. So int ID. Second member name, char name 50, semicolon. Third member address, char address 100, semicolon. Fourth member phone number, so int phone number. Fifth member mail ID, char email 100, semicolon. Sixth member HGPA, float HGPA, semicolon. Braces close, semicolon. So that is the syntax of our example, what I discussed before starting this slide, starting this presentation. So what are those ID, name, address, phone number, mail ID, SDPA? These are all member variables. Keep it in mind. Student is the structure name or tag name, and struct is the keyword. So this much is required for what purpose? To define a structure. And structure definition must be given by the user, because this is not the primitive data type. you must have to provide the definition of the structure. I hope this much you understood. Very next question, why we will declare this structure? Is it inside main or is it in global place, rather outside of main? The answer is very common because the answer is already discussed for different cases, different applications. If you declare it inside main or any other function, definitely that should be local to that very function. If you make it, if you declare it outside this main or in global places, so that structure is uh, declared, rather accessed, can be accessed, that structure can be accessed by any other functions except main if you declare it in the global place, means outside the main function. So again I am moving back to the slide that I just discussed. How to create a structure? Struct keyword is used to create a structure, just discussed. Second point, how to create a structure? Struct keyword is used to create a structure, and I just discussed how we create a structure. Fine. How we can create a structure means how we can define a structure. Next question. Next question. How we can use those structure? How we can use those structure? Means how we can use this data type. As earlier knowledge, as per our earlier knowledge, what we can say? We need to declare variables of this structure type. That is the solution. We need to declare the variable of this structure type. So I declare a variable, say according to our example, I declare a variable S1 of type structure student. So when I am declaring a variable of type student, the name of the variable is S1 I have given. So S1 must have all these 6 members, means ID, name, address, phone number, mail ID, and SDPA. If I declare one more variable named S2 of type struct student, then S2 must also have these 6. Similarly, here in this example, if I declare a variable, say X of type struct gigs for gigs, X has these 3 members. Try to understand. So I'm moving to the implementation part of the structure. I'm going to write a program through which we can show how we can declare a structure and how we can use those members in a structure. Let me share the programming screen with you. So first line will be the header file of the program, just like previous one. Second line, I'm declaring my structure in the global place. So I take the name of the structure as EMP, and I consider this EMP has three members. One is the ID, another one is the salary, and the third part is the name of the employee. EMP means it's an employee. And when I am completing the structure definition as per the rule, I must have to give a semicolon at the end of this structured definition. So this is the structured definition of EMP structure. My structure name is EMP. Try to understand. So now this EMP structure has this three members. One is ID, another one is salary, and the third one is name. Now I am trying to start of my main function. So how we can use this EMP structure? I just mentioned, to use this EMP structure, I need to declare variable of this struct type EMP. So to declare a variable, what is the syntax of this declaration? The syntax is struct EMP, say E1, comma E2. I am declaring two variables, employee 1 and employee 2 of EMP structure. So when I am declaring employee 1 and employee 2, that means employee 1 have these three members, ID, salary, and name, and employee E2 also has these three members, ID, salary, and name. Now, if you ask the question, what is the size of this E1 and E2? What is the answer? That means what is the size of the structure, better to say. Just like size of an integer is 4 bytes, size of a float is 4 bytes, size of a carry is 1 byte. We already know this. These are the primitive data types. Then my question is, what is the size of this EMP structure? Or when I am declaring the variable E1 and E2 of type EMP, definitely E1 and E2 have the size which is equal to the size of the structure EMP. So what is the size of struct EMP? Definitely the size of the structure we consider is size of first member, size of second member, plus size of third member, plus size of fourth member, plus size of fifth member, plus size of n members. Here we have three members. So what is the size of first member? It is integer, 4 byte. What is the size of second member? It is float, 4 byte. What is the size of third member? It is char name 100. Char name 100. So character is taking 1 byte here. So size of the character is 100. So that means it is taking 100 bytes, because 100 character means 100 bytes. So 100 plus 8, the size of this structure variable of definitely it is 108 bytes. So size of a employee, size of E1 and size of E2, each size is 108 bytes. So now what I am trying to do, I am trying to take the input of those members, ID, salary, name, for the variables E1 and E2, because I already mentioned when I am declaring the variable of this structured type of, in this case it is EMP, the point to be noted is Each and every variable must have these three members, as because three members is declared, rather defined inside the structure EMP. If the structure definition have five members, then the variable, all variables of that particular structure have those five members. So next question naturally comes, sir, how we can access those members, rather members like ID, salary, name through this variable E1 and E2. That I will show you through this program. So this is what? This is the declaration of structure variable. So what is E1 and E2? Note it down. This E1 and E2 are the structure variables. It is structure variables. And what is ID, salary, and name? These are all ID, salary, name. These are all member variables. So this is the difference between member variables and structure variables of structure when we discussed. So member of the structure and structure variable are not the same thing. Member variables is defined when the structure definition is given, and structure variable is required to use that particular structure, and we came to know that structure is nothing but a user defined data type. Fine. So we needs to define that data type. So when I am defining that data type, we need to declare different members of that structure. So very nice. So so far we have declared E1 and E2. If we write this line outside the main, that means if I write this line, this declaration syntax outside this main, that means the E1 and E2 are the global variable, just like the normal variables. If I declare a normal variable over here, int a, so what it means, a is a variable of type integer and is declared globally. And similar fashion, E1 and E2 also a structure variable which is declared globally. If I declare this line at the line number 8. So I have declared E1 and E2 locally inside main. So now my next task is I have to take input from the user, rather details of employee 1 and employee 2 from user, and I will I will just print those imports through program. That is the first objective of my structure programming. So how we can take the input from the user? So I am writing a line, say printf enter the details of employee 1. Enter the details of employee 1. Fine. So this is the line which will be printed in the output stream. After that, the scanf starts. First scanf is for the ID input. And what is your structure variable? This is E1. So E1 has all these three members, ID, salary, and name. So note it down. To access the data members of a structure, through structure variable, to access data member of a structure, which are the data members like ID, salary, name, these are the data members. To access data members of a structure through structure variable, who are the structure variables here? E1, E2. We need to use dot operator. So here in the scanf function, we have used dot operator, and definitely we have to give an ampersand before that. Very nice. Second input is salary. So I'm putting the another scanf here. %f ampersand E1 dot salary. Very nice. And the third input is, that is the name. To take a string input, we normally use what? Getis function that we learned. And what we have to write inside this getis as a parameter? The name of the array, character array. So here what is the name of the character array? That is name. And which is the member of variable e1. So that's why I have written e1.name. Understood? In the same way, I can take input for employee 2. This is the input for employee 2, employee 2.id, employee 2.salary, and employee 2.name. I hope you understood this much. What we are doing up to this, we have declared two structure variables of type emp, struct emp, that is e1 and e2. As and when I declared two structure variable e1 and e2. That means e1 and e2 both have these three members. The members which are defined inside struct emp, which are those members? It is id, salary, name. So what we are doing here we are just taking input for e1 as well as for e2, and after that we will just print the input set in the output string. So first, details of employee 1. Fine. I'm writing details of employee 1, not enter, only the details of employee 1. How can I print those? Same fashion. Structure variable name dot member variable. So for the first, it is e1. So I'm copying that part. Later on I will edit. It is printf, not scanf. It is printf. It is e1 id. So let me print /n id equal to, fine. Then what is the second part, second member? That is the salary, /n sal, rather salary equal to %f e1 dot salary, and finally the name. So printf /n name equal to. Very nice. So that will print the details of employee 1. Similarly, this code I will copy for employee 2 also. Very nice. So details of employee 2, fine. This will print e2.id. This will print, sorry, ampersand will not be there. This will print e2.salary, and this will print the name. The name is e2.name, fine. And finally, we have reached at the end of the program and return 0. That's because in main I have written. Fine, very nice. So let me execute the program. Fine. Let it be shared to you. So I hope you can view the output screen. So enter the details of employee 1. Which one is the first member I have taken? That is employee ID. Say I have given 100. Then salary 1200. Then look, a problem that I faced over here, the name part, it gets skipped. The input for the name of the employee gets skipped. Again, I am giving the input for employee 2. Employee ID, it is 200. Salary, say I am putting 1800. And again, that part also gets skipped. Details of uh, employee, that gets skipped. And employee 1, details of employee 1 showing, details of employee 2 is not showing. So this type of problem may arise not only in the structured programming, in other programming also. This is not the problem of specific problem of structured programming. This may arise in different problem also, that some scanf statement or some input statement just gets skipped. Why? This is the reason of the input buffer gets full. Input buffer gets full. The input is stored inside a buffer. When the buffer gets full, there is no more space to take more input. So that's why that scanf line or that get statement, rather the input statement, is just getting skipped and is moving to the next part. So that's why this input to the third input for employee 1 and employee 2, I cannot provide here. So the solution is, there is a statement to clear the buffer. The statement is what? It is flush std in. So where I am facing the problem, before this line, right now, before this get a statement, try to understand, because this statement just gets skipped. So before this statement, I must write a flush std in. Keep it in mind, don't need to write it for all the programs, no need to write it mandatory. If you face the problem, it may be the case, this situation I am facing, you may not face this situation. That means this skipped operation may not occur in your machine, because this is not a general problem. Maybe your buffer permits to take input, my buffer is not permitting. So that's why it is not mandatory to write flush std in all the time. First check it in the output screen. If this problem occurs, then mention flush std in to clear the buffer. Fine. So that is not the specific problem for structured programming. This is not, you may face this program in string also, string programming. And someone already faced, they already consulted with me. So this is not related to the structured programming only. And for the second case also, look, second case also, I have to write here before this name, I have to write flush std in. And another thing, I made a mistake just, that is to print the name, I have to write putes, not getes. That's why it is looking for input in the output screen. It should be putes, it is not getes. So this statement will be putes. So I hope now this program will run fine. Check it once again. Let me show you the output of this program. So details of employee 1. Say I've given the value 101 or 100, say. Second is the salary, that is 1200 I am giving. Yes, now this line is not skipping. Now it is taking input ABC. Giving the details of the second employee, say it is 101. Fine. The salary is 1800, and say name I am putting is XYZ. So the details of employee 1 is showing, it is ID 100, I need to change it printf. Instead of printf, let me check once again the program. Oh, again I have given scanf. That's why it is asking for some input from the user. Printf. It should be printf because I'm printing the details of the employee 1 and I'm printing the details of employee 2. Fine. Let me execute once again. Let me share the output screen with you. So giving the input for employee 1, this is 100, salary 1200, name ABC, fine. Details of employee 2, that is 101, ID, salary I am putting 1800, and the name I am providing XYZ. Look, this is giving, the output has come. So what this program does, this program is just basically declare two structure variable, that is E1 and E2. And when this structure variable declared, I just mentioned that this structure variable has these three members according to the definition of the structure. And I'm taking the values of those three members by using dot operator. And I'm just displaying that input set in the output screen. That is the objective of this program. Fine. So this way, I have declared a structure variable. In this line, I have declared structure variable struct emp e1 comma e2. This is an approach. An alternative approach is you may declare it in global plus. Fine. Another approach is you may declare structure variable in this plus e1 comma e2. It also works. So I can declare structure variable at the end of structure definition, and after that I can put a semicolon. So here also I can declare structure variable. Let me execute the program once again and check whether it is running fine or not. Let me share it. Employee 1, first input is the ID 100, second is the salary, say 1200, third is the name, that is ABC, fine, and the details of employee 2, it is 1800, sorry, 101 employee ID, second is 1800, and third is XYZ, that is the name. So it is working fine. So that is the alternative approach, that how we can declare structure variable. So one approach is struct emp e1 comma e2. You may declare it inside main. If you declare it inside main, it seems local. When you declare it global plus, that seems global. When you declare it e1 comma e2 with the structure value, with the structure definition, in this way also you can declare a structure variable. That is my objective to understand you. When I am declaring this variable e1 and e2 in this place, try to understand. When I am declaring the variable, structure variable, these are the structure variables e1 and e2. When I am declaring the structure variable at the end of structure definition, so in that case, I omit the tag name of the structure that I mentioned earlier, that this tag name is optional. This tag name is optional, but not in all the cases the tag name is optional. When I am declaring structure variables in different place, like line number 8, like line number 11, at those cases we must have to provide the name of structure, because it look like struct space structure name. Struct is the keyword, then name of the structure, then the list of the variables separated by comma. Fine. But when I am declaring those variables with the definition of a structure itself, so mention no need to mention the name of the structure anywhere in the program. So at that time we can omit the tag name of the structure. So that's why I mentioned earlier that this uh, tag name is optional to the structure program. So check whether it is running fine, whether it is working or not. Sorry, let me run the program. Yes, let me share the screen with you. Yes, so employee 1, employee ID is 100, then salary 1200, then name is ABC. For the employee 2 it is 101 ID, then 1800 is the salary, then XYZ is the employee name. Yes, it is working fine. So we can omit the tag name of the structure also, but it is optional, not for all the cases. When I am declaring variables, when tag name is not required, we can omit it. Fine. So another thing I must discuss, and that is the last topic for today's class, that is the using of a keyword type def. So before using that keyword type def in this structured program, let me understand you. Let me understand a simple program. Uh, let you understand a simple program using this type def. Fine. Let me write the program. I'm writing a very simple program. I hope you understood. Int a equal to 5. Fine. I'm writing printf %d comma a equal to. Fine. And there is a return 0 statement. Very nice. So if I execute this program, I will get the output 5. Compile and run, sharing it with you, and the result is a equal to 5. This much we all know what is the meaning of this. Now I am modifying it. Say I am writing type def. This is the keyword, that's why it gets highlighted, it gets bold. Type def int a, and in the very next line I'm writing a space b equal to 5, and I'm going to print the value of b by using b equal to %d comma b. So what is the meaning of this? Try to understand. What is the meaning of this? When I have written only int a, that means a is a variable of type integer. Fine. When I am writing when I am writing type def int a, the meaning of this is a is type defined as an integer. A is type defined as an integer. What is the meaning of this line? A is type defined as integer. The meaning of this line is, in line number 5, when I am writing a space b, forget about this 5, a space b, What is the meaning of this line? The meaning of this line is B is now declared as type int, but I haven't written that line int B. Still, B gets declared as type int. How? As because in line number 4, I have written that A is type defined as integer. So A, after writing this line number 4, A will not behave like a variable. A will behave like a data type. Which data type? Integer data type. Why integer data type? Because I type defined A as integer. If in place of int, if I write if float A, type defined float A, that means A is type defined as float, A is type defined as float, and when I am writing A space B, B is a variable which is declared of type float, because A, now A is not a variable. A is behaving like a data type. Which data type? Now it is float, earlier it was int. When I've written this int, that means A is type defined as integer and B is a variable of type int. And if you use the scanf statement, it will work. Let me use a scanf statement over here. Scanf %d, comma, ampersand B. And in the next line, I am going to print the value of B. Let me execute the program and show you the output. Share content. So I'm giving the input of the value B, say it is 15. Look, the output of B comes 15. And if you change the data type, make it float. So that means A, the variable A will not a variable, A is not a variable right now. A will behave like a data type as because A is type defined as float. In the very next line, when I have written A space B, that means B is a variable of type float. Then when I am writing scanf, I must need to write a %f over there. And when I am printing the value of B, need to change. Fine. Let me run the program. Again, try to share. Yes. Say 100.5. That is the input I am giving. Look, it's coming. So this is the keyword type def can be used for anywhere in the program, any program, not only structured program. Now my next objective is I have to use this type def in the structured program. So when I'm writing this type def before this, try to understand type def struct, say I'm providing the tag name also, though it is optional now, and I'm writing instead of E1, E2, I am writing E here. Fine. So what is the meaning of this? Earlier, when I have not mentioned this type def, what is the meaning of this? The meaning of this is E is a structure variable of type EMP. Try to understand. E is a structure variable of type EMP. That is the meaning of this line. When I am writing type def struct EMP, that means E will no more behave like a variable. E will no more behave like a variable because E is now type defined as struct EMP. E is now type defined as struct EMP. And when inside main, if I write E space instead of line number 11, earlier line number 11, if I write E space E1 comma E2, so what is the meaning of this? It is equivalent to struct emp E1 comma E2, because I already type defined E as struct emp. I already type defined E as struct emp, and as because when I am writing E space E1 comma E2, that means E is now behaving as a data type struct emp. So that is the utility of this keyword typedef in perspective of structure. So let me execute the program and check whether it is working or not. Giving the input of the first employee, that is employee ID, so it is 100, salary 1200, name ABC, second employee ID say 101, salary 1800 I am taking, and the name is to before ending the session, today's session, one more thing I must show you through this programming example, that is the size of the structure that I already discussed with you earlier of this lecture when I am starting about this topic structure. So I mentioned the size of the structure variable will be definitely the size of member 1 plus size of member 2 plus size of member 3 plus size of member 4 plus size of member n. So I will show you that yes, that thing here the discussed member, this discussed structure have these three members, that is ID, salary and name. So I already discussed the size of ID is 4, the size of salary is definitely 4, and the size of name variable is 100 because it is a type character and 100 size. So definitely 100 bytes. So 4 plus 4 plus 100, that is 100 bytes. So if I print the size of E1 and E2, which are the type of employee, or rather type of EMP, variable of type EMP, so definitely what will be the size of E1 and E2? Let me check the output, write the code for that purpose to show the size of E1 and E2. So printf %d, let me write /n, size of equal to %d, size of what? Size of E1, right now. I'm going to print size of E1 %d comma size of E1. Fine. So I hope this will return the size of E1, and in the very next line I will print the size of E2 also in the same way. Just make it copy and paste it. Size of E2 will be returned by size of operator on E2. So let me check how much it will give. Let me share the output screen with you. Check for the first employee, it is 100, salary is 1200, name is ABC, second employee it is 200, employee ID, say 1800 is my salary, and XYZ is the name of the second employee. Look, size of E1 is showing 108 and size of E2 is also showing 108, and we already discussed the size would be 108 because three members are there. First one integer taking 4 bytes, second one float taking 4 bytes, third one it's a character array of size 100, so that means 100 bytes. So 4 plus 4 plus 100, so result will be 108. That's why 108 is coming at the output of size E1 and E2. So I hope this much is clear to you, and this is the preliminary discussion of the topic structure. And the next lecture I will continuing my this topic structure, and many more uh, concepts are there regarding this topic structure. So thank you very much.